In this presentation, geothermal energy and its positive and negative externalities will be discussed at an economic standpoint. The demand, dependability, benefits, economic stimulations, types of geothermal systems, hotspot areas, and costs will be discussed in this presentation. As the world's population grows, so does the demand for clean energy. As more developing nations put their hands into the world's limited pool of natural resources, renewable energy is vital for our future of sustainability. Developing nations, as well as ours, uses coal and oil for a significant amount of energy production. This limited supply of fossil fuels does provide negative externalities, such as a coal-burning power plant producing 994 kilograms per megawatt hour of CO2 and other air pollutants versus zero air pollutants from geothermal facilities. Some population-dense areas receive large amounts of air pollution and even acid rain from heavy reliance of fossil fuels. The cleaner alternative is here. This form of clean energy is appealing at an environmental standpoint since only 404 meters squared of land per gigawatt hour are required versus 3,642 meters squared of land for a coal plant. The relatively small size of the physical plant for a geothermal facility and eliminating the need to transport fuel means a small environmental impact and a small cost. These facilities must be built in areas with rift zones and natural geysers or hot springs. In the economic sense, the low cost to operate this kind of facility and the efficiency of the energy production machines will well overcome the initial startup costs. That sounds appealing, doesn't it? Now let's talk about why we should rely on it. Geothermal energy is nearly endless in supply if managed properly. Geothermal hotspots recharge at a quick rate, and responsible extraction methods will prove beneficial for many years. Unlike solar energy, which provides the peak amount of power during the daylight and a small amount during the night, geothermal provides a stable amount of energy regardless of the weather conditions. Geothermal is also dependable and relatively inexpensive due to its facilities' designs. The power is derived from steam pressure by introducing water to the Earth's heat, which is then used to turn a turbine that channels energy to generators to store energy for a later time. Increasing our investments into geothermal energy and increasing our scales of operation will secure our energy future. With the almost non-existent carbon footprint of geothermal facilities, federal compliance on emission regulations is relatively easy. Geothermal energy facilities, as a primary energy provider, would eliminate costs that are spent reducing pollution and could then be redirected back for further development and lowering utility costs. To maximize the benefits of this clean energy, state or federal governments can oversee the facilities to keep costs down or issue subsidies to consumers if owned by a private firm. If the state or federal governments own the facility, consumers can receive a tax break to offset these costs of energy, although already low. The private firm that will be contracted in a competitive market will be the one who can supply the energy at the lowest cost. This competition will bring about an efficient and cost-effective way of energy supplication. The negative externality of breathing dirty air from coal plants will be eliminated and the ecosystem will thrive. Further benefits include multiple uses of these facilities in conjunction with the energy production. Agricultural crop growing, fish farming, and snow melting operations can also be activities that can happen with the nearby geothermal facility to further maximize the benefits with little or no additional costs. As mentioned, the Earth's heat, met with water, creates steam, which is harnessed to power a turbine and store energy in a generator. This process holds true over the geothermal systems, but there are a couple of different variants in design. The first type of geothermal facility is the dry steam power plant and is the grandfather to all our more modern types. The dry steam model channels steam directly to a turbine to provide power to the generator from a natural geyser or hot spring. The next type is the flash steam style, which is the most commonly used today. This system is a bit more complex since water at high temperatures is pumped into a separate chamber that is at a lower temperature to create vapor that powers the turbine and generator. The final system is a closed-loop binary system. In this system, the fluid passes through a heat exchanger, which will then convert the fluid to vapor that drives the turbine and generator. This process occurs in a separate chamber where the steam does not make direct contact with the generator. These are the systems that have proven dependable to us. This map of the United States displays the areas that can be utilized for geothermal energy productions. Among the most popular areas are rift zones in the western United States, including Idaho, which has a good amount of favorable locations for a facility. Several have already been built and are in operation as articulated by the black dots. The western United States is the most favorable for these facilities, and the eastern United States is among the least favorable. It's great to see that a part of the United States is producing and using clean geothermal energy, as the demand will continue to rise for the future. As mentioned earlier about the economic activities that can work in accordance with a geothermal facility, home and swimming pools can be heated as well. Geothermal facilities are stout promoters of efficient heating and cooling. Overall energy consumption for heating and cooling is reduced by using geothermal systems because of their heat pumps being 70% more efficient than conventional systems. The annual costs of heating and cooling are the lowest using geothermal at right around $400 versus propane that can reach above $2,500 a year. The future of ever-growing energy consumption can be met by utilizing our nation's natural geysers and hot springs for energy. We are constantly striving to become more efficient and reducing costs, so why not use a clean, dependable form of energy to do this? Geothermal energy has been used and successful since the early 1900s, and the improvements that have been made in the meantime have proved useful to our needs. Here's to the future of clean, renewable energy.